Let's go to question number 62, unique path. This is medium question. Let's get into it. Our robot is located at the top left corner here of n by n grid. The robot can only move either down or right at any point in time. The robot is trying to reach the bottom right corners of the grid. This is the finish line. How many possible unique paths are there? Okay, let's check the 3 by 2. 3 by 2 here, and then this is finish. So first case is going right down, and then right down right, and then down right. There are 1, 2, 3. So return is 3. How are we gonna do? That's right. Maybe we can use the DFS. So DFS is backtracking. So if the robot is out of matrix, we use backtracking, and then when you arrive the finish, we increase the counter. Okay. Let's implement it. Def. DFS, and it's allowing column. And if that is in boundary, m allow, and then allow is from 0, and column n. This time base case if allow is finish is n minus 1, right? m minus 1, and column is n minus 1. At this time we needed to sub count increase 1, and then now we move to next down, move down, and move right. And then I will initialize self counter 0, and therefore robot position is 0, 0. So return self counter. In this time this is accept, but when you submit we will get the TLE because we need to make a better solution. Okay. Is there any idea to make it better? That's right. Answer is DP. Okay, let's solve with the DP again. So first, I would like to use the DP table. Size is the same as the grid. So first, let's think from the finish. When we here, going to here is way is only 1, right? This is only 1. That is the exactly this place. And then in this case, left side it has how many? Down and right. But in this case, down is out of the matrix, so there is only one way. Same way, this one also all is 1. Does this make sense? And then how about this one? This one cannot go, so 1, 1. Okay, how about here? In this case, it not only go to down, but also go to right side. So it must be this one plus this one, right? So this is 2. And then in this case, 2, 1, 3. And then in this case, 2, 1, 3, 4, 5, 6, 7. And then this is 6, 10, 15, 21, 28. So in this grid, answer is 28. Let's check. Okay, 28, correct? Alright, okay, so first we need to make a DP table. DP table initialize with 0, and then multiply column first. Be careful, this is not m, and first, and for I in range m. So we made the n by n matrix, and the first I will fill the finish is -1, that there are only one way, so dp -1 must be 1, and then fill here. So for allow in range n -1, right? And then dp allow n -1 must be 1. For column also in range n -1, dp minus 1. Column also 1. Okay, now we need to fill this part here because we fill 1 1 1 1 1 1 1 1 1, right? So which one first? Here first, here first. That's right, here first. So here must be here plus here, right? So we will implement this one. So this one position is must be n minus 2, comma n minus 2, right? For now will be start range n minus 2 to 0 and then minus 1 by 1. For column also in range n minus 2, minus 1 and minus 1. Now dp row and column must be dp row plus 1 column plus dp row, not row, column plus 1. Does this make sense? And then finally I will return dp 0, 0. Okay, let's check the code. Okay, looks good. Let's submit. Awesome. In this case, time complexity is the linear time because we use only the field dp table. Is the big O m multiply n, and then space complexity also linear space m multiply n. Thank you.